Bismillahirrahmanirrahim. Dear students, I am Shafqa Shahidul Chandabaloj, lecturer in Department of Basic Science and Related Studies, Mehran University of Engineering and Technology, Jamshoro. In this series, we are going to discuss the subject linear algebra and analytical geometry. These subjects consist of the three CLOs, the course learning outcomes, which means that at the end of the course, a student should be able to perform the basic operation of the matrix algebra and be able to solve the system of linear equations. And second one, to develop the concept of 2 and 3 dimensional geometry and also the multiple integral to analyze the area and volume of the bounded regions by using the multiple integrals. So these are some books that I will recommend to you for this series of the course. Some of the links are also available in description. You can download few of these books. So now let us move forward to see and have introduction about the linear algebra and analytical geometry and also for the multiple integrals that we are going to discuss in this series of this course. From the knowledge of the calculus, we know that in science and engineering, there are a number of situations when we deal with the variety of equation to find the value of one physical quantity in terms of the other when they are related. For example, relationship between the temperature scale is F is the Fahrenheit here and C is the Celsius. Now notice this relationship is a linear and we can also write in terms of y the function of x, and here we can also say that f is a function of C, the Celsius. Also note that this relationship is a linear. Power in a DC circuit is defined by the equation P is equals to V square upon R, in which P is the power, V is the voltage, and R is the resistance. Now notice that in this P is a function of V provided R is a constant. So V is the function of X, Y is the function of X, here power is the function of voltage V. Now further, also noted that this relationship between the power and the voltage is a non-linear one. But beside this, there are also some situations where physical quantities form a system of the similar equation, especially when these are linear equations in which the quantities are related in similar form of equation. For example, in this electrical networks that is shown by the diagrams, if you apply the Kirchhoff's law, you will get the equations in the form of system of linear equation which are I1 minus I2 minus I3 is equals to 0, and then minus 10 times I2 plus I3 is equals to 10, and 20 times I1 plus 10 I2 is equals to 5, which is a system of linear equation where I1, I2, I3 are the currents into the circuit. Now the problem is to find the values of the unknown I1, I2, I3, which we can call as the solution of the system of linear equation, which can satisfy these three at all one time. Now for such type of system of linear equations, we can apply the concept of linear algebra, whose central theme or central idea is to find the methods or techniques to solve the system of equations. Furthermore, let us see three cases of the system of equation. So each of these three systems consists of the two equations which are the linear equation or equation of the straight line. Geometrically, when you plot the equation in xy plane, you will get two straight lines. So let us plot this equation one by one. So from the first one, it can be seen that these two lines are parallel to each other on the xy plane. So let us see the second one. The lines are intersecting at a one point, and the line coincides on the third one. So now geometrically, what we can say about these three cases. So in the first case, since we can see the lines are parallel, which implies that there is no point of intersection and hence there is no solution. So in the geometric interpretation of the second case, when the system of equation in the figure has only one point of intersection, so which means there is only one solution. And similarly, when we can see there are infinitely many points of intersections, which implies that there are infinitely many solutions. So Now question is that how we can identify whether the system is consistent means having solution or it is inconsistent having no solution. So we shall discuss whether the system is consistent or inconsistent in the consistency criteria in the linear algebra. So now let us move further for the concept of analytical geometry. Analytical geometry is also called the coordinate geometry. Coordinates are used to represent the position of the point on the real line or in plane or in space, the three dimensions. Suppose we are on a line, then we can assign the numbers to each point on this line, selecting the 0 point as the origin and plotting all the points on the right side as the positive numbers and all the points on the left sides are as negative numbers. So this point is origin, all the positive numbers and the negative numbers is also called the coordinate line. Since the numbers are real numbers, so we can also call this line as the real line. This line is usually denoted by R. Now suppose that if we have a point in a plan, then we can locate its position with the help of two coordinates, one along the horizontal axis, usually called x-axis, and other along the y-axis. Suppose we have a point in two dimension or in a plan, then we can locate its position with the help of two coordinates, one along the horizontal line, horizontal axis. These both lines intersect perpendicularly at origin. To locate the position of this point, we move x units along the x-axis and then we move y units parallel to the y-axis. So the numbers x, y are called the coordinates of the point in xy plan or in two dimensions. In three dimensions, the coordinates of the point P are in the form of order triple of the numbers x, y, z, and these x, y, z are the real numbers. We can also represent the three dimension in the form of r power 3 or r3. To locate the position of this point P in three dimension, we can draw a cube. To locate the position of the point P, as shown in the figure, we shall first move from the origin, the point O, along the x-axis to the point X, and then we shall move parallel to the y-axis, and then we shall move parallel to the z-axis to the point P. So in this case, this will be the position of the point P in three dimension, whose coordinates will be defined by x, y, z. So now let us move further and take a situation to understand more about the analytical geometry. Let us take a situation where two plans defined by the algebraic equations, and suppose that we draw this plan into the three dimension. Then now notice that in this figure these two plans are intersecting and then there exists a line. Now to find the equation of this line of intersection as shown in the figure, we have to move forward for finding the 2 points on the line. The first point can be obtained by substituting z is equals to 0. We will get a system of linear equations in two unknowns x and y. Suppose that is system 1. Solving, we will get the coordinates of the first point, say p1, are 1, 2 and 0. Similarly, can be obtained by substituting x is equals to 0. So we will have, and solving, and we will get a system of equation that is defined by 2. Now solving, we will get the point 2 defined by the coordinates 0, 1 upon 2 and minus 2. Equation of this line then will be defined by the symmetric form obtained through these 2 points is x minus 1 upon 2, y minus 2 upon 3 and is equals to z upon 4. Now notice that by finding these 2 points to find the equation of the line intersecting these two planes is actually obtained by solving the system of linear equation. So which means we can now say that the central idea is also for analytical geometry, that we will use the concept of algebra to analyze or investigate the properties of curves and figures in analytical geometry. So now let us move forward for our third portion, multiple integrals. Now our third portion is the multiple integrals, And from the knowledge of the calculus, we know how to find out the indefinite and definite integration of certain function. For suppose we want to find out integration of function x with respect to x, and we know this will be equals to x square upon 2 and then plus constant c, that is the constant of the integration. We can also find out the integration of the same function x from x is equals to 0 to x is equals to 1, and then here you can apply the fundamental theorem of the calculus and you will get 1 upon 2. And we also know from the calculus that the definite integration helps us to find out the area. Here we have to find out the area between the points A and B enclosed by the two curves f and g, where f is the upper and g is the lower curve, and we can see this shaded area enclosed by these two curves, and that can be obtained using this formula of the definite integration that we can obtain from knowledge of the calculus. Now this same can be obtained by using the help of the multiple integrals. For example, we want to find out the area, the same area. Then we can use the concept of the multiple integral. In that case, D is the region enclosed by these two curves. So here we can apply this formula to find out the area. Now furthermore, we can use the general formula for finding the area and volume enclosed by the two curves. Let us see. Now using this multiple integral, we can obtain our area and volume by substituting f is equals to 1 or f not equals to 1. So as far as the multiple integration, besides finding the areas and volume, we will also discuss some of the techniques to find out different types of multiple integrals. Thank you for watching this video. See you soon in the next lecture, that is about the matrix theory and types of matrices.